Welcome back to Talk Tensors. I am so excited for today's deep dive because we are looking at LayerAnimate, layer-specific control for animation.
Really cool paper.
Yeah, it just landed on the ArcSiv preprint server, like earlier this year, 2025, coming to us from some researchers at the University of Chinese Academy of Sciences,
Oh, wow.
Tsinghua University, and CreateAI.
Interesting.
And, we've all seen these tools. You type in a text prompt like a cat chasing a mouse, and you get this like animation out.
Right?
But it's like all one thing, right?
Yeah, you don't really have that much control over it.
Yeah, so this is really getting at like precise control.
Finally giving us control over these AI-generated animations.
Yeah, so how is this different? What's going on here?
So traditional video generation models, they kind of treat the whole animation as one unit.
Like one big image.
Exactly. So you can't really tweak the individual elements like you would in, Photoshop with layers.
Like what if I want to change the background?
Or add special effects or, just tweak the cat's movement a little bit.
Or switch out the cat for a dog.
Exactly. It's really been a challenge up until this point.
So LayerAnimate is offering us Photoshop for animation.
That's a great way to put it. It introduces this layered approach, just like professional animators use. You can isolate the characters, the background, the effects, have them as separate layers, and then you can adjust each one independently, add new ones, combine them seamlessly.
But how did they pull this off?
That's the cool part. So layered animation data is very rare.
I bet.
Animation studios guard that stuff like it's gold. So the researchers had to get creative.
Okay, how'd they create their own layered data then?
They developed a 3-step pipeline. The first step is using AI models like SAM and SAM2
To do what?
to automatically segment different elements in a scene.
Segment.
Yeah, so imagine you have a picture of a busy street. SAM can identify and outline each individual car, pedestrian, building. That's segmentation.
Okay.
So they use that to separate out the elements of an animation. But then it's not just segmenting each frame, because then you think about like a character walking, the arms and legs are moving, so you could end up with like each limb as its own layer.
Oh, right. Too much.
Yeah, that's over-segmentation.
Yeah.
So that's where the second step comes in motion state hierarchical merging.
Okay, what is that?
So this analyzes how the elements move and groups them based on their motion scores.
Which are calculated how?
Using something called optical flow.
I feel like we need an ELI5 here. Optical flow. What is that?
So when you watch a river flow and you can see how the water moves and swirls?
Yeah.
Optical flow does the same thing for video. It tracks how the pixels move between frames.
Oh, okay.
So by analyzing these pixel movements, the researchers could determine which elements move together and should be grouped as a single layer.
Oh, that's smart.
Like the AI is learning to see the movement patterns.
Just like a person would?
Exactly. And then to top it off, they added a third step, motion coherence refinement.
That's a mouthful.
It is, but it's very important because it helps filter out tricky scene transitions that could fool the segmentation.
Like what?
Imagine like a scene where smoke is gradually appearing.
Oh, yeah.
A basic segmentation algorithm might struggle to differentiate the smoke from the background, but motion coherence refinement ensures that they're separated properly.
I see. So it's like making the data even better.
Yes, very clean and robust data.
Okay, that's super clever. But data preparation is only half the battle here, right? How does LayerAnimate actually use this layered data to create the animations?
That's where it gets even more interesting. LayerAnimate goes beyond simple text prompts by incorporating motion information.
Motion information, meaning?
So firstly, they use those motion scores that we talked about from the optical flow calculations to guide the animation process.
So like instead of saying make a bird fly, you can actually specify how it flaps its wings.
Exactly. You have much more granular control. And secondly, they use sketches.
Sketches.
Imagine you want to animate a character kicking a ball. You could just sketch the rough outline of the leg movement.
Okay.
And LayerAnimate will use that as a guide to generate the full animation.
Whoa, so it's like I'm actually animating.
In a way, yes.
Very cool.
And then to bring it all together, they use something called masked layer fusion attention.
Masked layer fusion attention.
Yes. It's a key component that allows LayerAnimate to intelligently combine the information from all these different layers.
Why they need that?
Well, imagine you're combining layers in Photoshop. You could get some weird visual glitches.
Oh, yeah.
This prevents that. It makes sure everything looks seamless and professional.
Oh, okay. So it's like the conductor of an orchestra, making sure all the instruments are playing together nicely.
Right, analogy.
So just to recap for our listeners, LayerAnimate is this new AI animation tool that uses a layered approach to give users unprecedented control.
And don't forget the three-step process to create the layered data and the use of motion information through optical flow and sketches.
Right? All while keeping everything visually smooth, thanks to the mask layer fusion attention.
It's a very impressive system.
It really is, and it's amazing how they solved that data challenge.
Yeah, that alone is a huge contribution.
For sure.
Okay, so now we've kind of gotten to the nitty-gritty of like how LayerAnimate works,
Yeah,
but how well does it actually perform?
right. Do we have any, numbers to look at?
Yes, the researchers compared LayerAnimate to a bunch of other state-of-the-art video generation models using a bunch of different metrics.
Okay, so what kind of metrics are we talking about?
Well, they use things like FVD, FID, LPIPS.
There's a lot of acronyms.
I know, sorry, but basically these are just ways to measure the quality and the realism of the generated animations.
Okay, so can you give us like a ELI 5 for one of those?
Sure, so take FVD, for example, Frechet video distance. It measures how realistically the AI-generated video moves compared to real footage.
Oh, okay, so it's is it moving like a real thing, or does it look like janky and weird?
Exactly. You want smooth, natural movements.
Yeah, got it. So how did LayerAnimate do on these metrics?
It did really well. It consistently outperformed the other models on most of the tasks.
So it's making better animations.
Yes, higher quality, more realistic, more accurate.
Okay, that's great to hear. But I'm also curious about the visuals. Numbers are one thing,
Right.
but did LayerAnimate actually deliver on that promise of fine-grained control and really stunning results?
Oh, absolutely. The paper has a ton of examples.
We'll be sure to link those in the show notes, everybody.
Yes, definitely check those out.
Okay, so what were some of the highlights for you?
Well, there's this one example with like a superhero flying through a futuristic city,
Okay.
and it has all these like glowing particle effects trailing behind them.
That sounds cool. Was it able to do that and still keep the character in the background sharp and detailed?
Yes, exactly. It was very impressive. And, remember how we were talking about the challenge of animating things like smoke or fog appearing gradually?
Right, because traditional methods would mess up the background.
Yeah, because they treat the whole frame as one unit, but LayerAnimate handles this perfectly. The background stays intact while the smoke just billows out realistically.
Wow, that's amazing.
All thanks to that layered approach.
So it sounds like LayerAnimate is really living up to the hype.
It really is.
Now, I do have to ask, are there any limitations to this approach?
Well, as with any new technology, it's still early days for LayerAnimate, and there are some areas where it could be improved.
Okay, so what are we talking about?
One of the main limitations that the researchers highlighted is that it can't really handle new elements appearing in future frames.
Oh, so if I wanted to animate a scene where a character pulls out a sword that wasn't there before.
Exactly. That would be tricky for LayerAnimate. Right now, it's mostly focused on controlling the elements that are already present in the initial frame.
Okay, so it's like you're working with a set of building blocks. You can rearrange them and animate them, but you can't really create new blocks.
That's a good analogy.
But even with those limitations, the results are still pretty incredible.
Oh, they are definitely groundbreaking.
I'm sure a lot of our listeners are minds blown right now thinking about all the possibilities.
Yeah, I mean, this could really revolutionize the animation industry.
Yeah, totally. But before we go too far down that road, I'm curious, did they do any user studies with this?
They did. They had participants compare the output of LayerAnimate to other models.
Okay, and what did people think?
They loved it. They consistently rated LayerAnimate's output as the best. They praised its quality, its controllability, and how easy it was to use.
Oh, wow. So it's not just the researchers think it's good, actual people are responding positively to this.
Exactly. It has the potential to really resonate with artists and creators, not just AI researchers.
I think it's helpful to take a step back here and look at where we came from.
You mean the history of animation technology?
Right, because sometimes we get so caught up in the latest shiny new thing that we forget about all the steps that got us here.
You're absolutely right.
So let's take a little detour, shall we?
Yeah, I'd love to. All right, so we've talked about, the technical details of LayerAnimate and how it works.
Yeah.
And we kind of look back at the history of animation.
Right, how we got to this point.
But I think the really interesting question is, what does this mean for the future of animation?
Right, where do we go from here?
Whenever there's a big technological leap like this, there's always that fear that, it's going to replace human jobs.
Yeah, are animators going to be out of work now?
That's the question, right? But I think it's also important to consider that, new technology often creates new opportunities.
It's not always a zero-sum game.
Exactly. Look at what happened with digital photography. It didn't kill traditional photography.
Right, it just kind of changed things up.
Exactly. It created new styles, new ways of storytelling.
So maybe LayerAnimate won't replace animators, but it'll change the way they work.
I think that's very likely. Instead of spending all their time on the technical execution, they could focus more on the creative aspects, the storytelling, the character design.
Right, they become more like directors almost.
Exactly. Guiding the AI, refining its output.
Using it as a tool to enhance their creativity.
That's the idea. And as this technology becomes more accessible, it could actually lower the barrier to entry for aspiring animators.
Oh yeah, anyone can make animations now.
Imagine a whole new generation of creators telling their stories through animation, regardless of their technical skill.
That's a really cool thought.
It could democratize animation in a way that we've never seen before.
It's like what happened with independent filmmaking when digital cameras and editing software became affordable.
Exactly. Suddenly, anyone could make a movie.
Yeah, and maybe LayerAnimate will have that same impact on animation.
We could see an explosion of animated content, not just in movies and TV, but in education, advertising, social media, you name it.
The possibilities are pretty mind-blowing.
They really are. But with all this potential comes a need for careful consideration.
Right, we can't just ignore the potential downsides.
As we hand over more creative control to AI, we have to think about the ethical implications.
Absolutely, we need to make sure it's used responsibly.
And speaking of thinking outside the box, that brings us to our novel notions segment,
Yes, my favorite part of the show.
where we take the ideas from the paper and we kind of extrapolate and speculate a little bit.
All right, let's get speculative.
Okay, so we've talked about how LayerAnimate allows you to manipulate existing footage, add or change elements.
Right.
But what if we could take that a step further? What if instead of just editing existing footage, we could create entirely synthetic realities?
Whoa, you're talking about like generating video that's not even based on real footage.
Exactly, completely fabricated from scratch.
So like I could create my own virtual reality experience.
Exactly. You could visit any place, real or imagine, interact with any characters, live out any scenario you can think of.
It'd be like stepping into a video game, but like a super realistic one.
And it wouldn't just be for entertainment. Think about education. Students could experience historical events firsthand, explore the human body from the inside out, even simulate complex scientific experiment.
It would completely change the way we learn.
But it also raises some really interesting questions.
Yeah, like how do we even know what's real anymore?
Exactly what happens to our sense of reality when anything is possible in the digital realm?
Those are some deep questions.
And they're questions we're going to have to grapple with as this technology keeps advancing.
It's not just about the technical stuff anymore. It's about the philosophical implications.
It's about the future of our society.
Well, that got pretty existential pretty quickly.
It's all part of the fun of novel notions.
Right? Just us speculating wildly.
But it's important to think about these things.
Absolutely. And on that note, we'll leave our listeners to ponder these possibilities.
Don't forget to check the show notes for a link to the LayerAnimate paper if you want to dive deeper.
All right, folks, that's it for this episode of Talk Tensors. Thanks for joining us on this deep dive into the world of AI and animation.
We'll see you next time.
And until then, keep exploring, keep learning, and keep those novel notions flowing.